one, both on Zoom and in LinkedIn and in your home offices. So thanks for joining us. Today we're going to talk about API security with Stepan Ilyin and Tim Erlin. Why don't you introduce yourselves, gentlemen?
Sure, I'll go first. I'm Tim Erlin, and I am the head of product at Wallarm, and I'm happy to be here to talk about API security with you folks.
Hey everyone, thanks for having me. So I'm one of the co-founders of Wallarm. So as always, I'm here to talk about API security products, and Wallarm products, of course. So feel free to ask any questions if you guys have. Frankly, it's not only about API security, but it's more about product security, application security, API security. So whatever questions you have and you think it's relevant to what we're talking again today, just shoot a question LinkedIn or Zoom here. We're happy to incorporate some of them into the flow today. So Chris will help us with making sure we're not missing anything important here.
Great, thanks. And just for everybody, it's always a good question. Yes, this event is being recorded, and we will be sending a follow-up email with a link to the recording and the slide deck. So if you want to share with your colleagues or you missed something and you want to review it, we will make that available later in the week or early next week. So I think with the housekeeping out of the way, well, last thing, and just to reiterate what Stepan said, which is, leave us your questions. We'll answer them as we go, or, save a little bit of time at the end to answer your questions. So feel free. So with that, gentlemen, why don't we get started?
All right, fantastic. Thanks, Chris. So we're here to talk about three key principles for API security. But before we dive into those principles, I thought we could start with just a little bit of a discussion about why we're talking about APIs in the first place. The reality is that there are any number of topics around cybersecurity that we could be covering. So why are APIs the important topic that we feel like we need to talk about today? And the first way to sort of examine that question is to look at some recent API security incidents that occurred. So we pulled out 3 incidents from this year, all from this year, that we thought were worth just bringing up in this context. The first is an incident that occurred with T-Mobile back in January. And if you're in the cybersecurity space, it would be honestly hard for you to have missed this incident. I know breaches and compromises occur so frequently that it's hard to keep track. But this was a big one. It affected 37 million customer accounts, and it was a bad actor through a single API. And so it's relevant to API security in particular.
I think this was the first time that in the SEC findings, the company actually was talking about API security and the breach because of the APIs, which was kind of funny. You open this, financial statement and you basically read, hey, there was an incident occurred because of the authenticated API. So you're technical, reading the technical details of the breach right in the SEC findings.
In the SEC filing, yeah. That's maybe a milestone that we shouldn't be too proud of, but a milestone nonetheless. Yeah. Totally. So the second incident we wanted to surface is a vulnerability that exists that was found in April of 2023 that allows attackers to bypass authentication, essentially. So this is JWT token-based authentication in Google's ESP product, ESP v2. This is a critical vulnerability. We haven't seen a documented or confirmed exploit yet, but it's also the kind of incident we need to pay attention to, a vulnerability that could impact a lot of services, a lot of folks, and so it's important. And then the third one is this incident with Honda, which was a security researcher who used a series of vulnerabilities to actually accomplish a number of objectives. We sort of summarize it with gaining administrative access and exposing thousands of records, but there were multiple steps in this particular, I'll call it an exploit chain. Started with an unauthenticated password reset API. They then used a predictable user ID to impact users other than the authenticated user, and then some broken object permissions to gain administrative access further. Interesting incident that occurred, but also very specific to API security and APIs in general. So while these incidents are particularly relevant, and I like to talk about incidents that have occurred, they're the outcome, not the cause. They're at the end of the process, not the beginning. So why are we seeing these API security incidents now? And it has a lot to do with the changes in the tech stack that organizations and companies are using to implement services. So we're seeing an incredible growth, and this is not new, but an incredible growth in the number of technologies that are available that allow an organization to very quickly deploy new services using APIs and using new API protocols. And that creates new attack vectors, and new threats come with those new attack vectors. So you can see the development of the OWASP, the development of the OWASP API security top 10, which is different from the OWASP top 10. These changes in technology, they also, because of the speed of growth, they create blind spots for existing security tools. And those are blind spots that attackers want to take advantage of. Attackers tend to follow the attack surface. There's also another impact, which is that the more new technology you have, the newer that technology stack, the fewer best practices professionals, developers have to rely on for how to build securely with those tech stacks. So that change in the tech stack that we've seen has really driven that growth in API security incidents as well. And so at the end of that, we can say that APIs and apps are both exploding, no pun intended. The exploits are coming along with them. I really like this picture of an iceberg, because it gives you a sense of what that threat landscape or that attack surface looks like. There are certainly public APIs that people have to worry about. You have to worry about the APIs that you're exposing to the world. There are also partner APIs. And then below that sort of waterline of public access, there are private APIs, which are growing at also sort of an exponential rate. And those private APIs present an attack surface that's a little bit different than publicly exposed APIs, but is an attack surface nonetheless. And so it's important to keep in mind that we're talking about sort of this iceberg looking threat landscape or attack surface. And Stepan, did you want to talk a little bit about the growth and exploits here?
Yeah, totally. Like if you guys have been to our webinar before, and Chris is the author of the research, we basically did a 10-year retrospective of API vulnerabilities. And the idea was basically collect everything we can find about API security issues, like all the CVEs related, all the bug bounty reports that people submitted. And apparently there are like a lot of API vulnerabilities. If you just like make a summary and kind of like a few metrics, you will learn some fascinating things. For example, like every day there's like 5 new API exploits. This is only what we know. This is not only those that are published. And of course they are related to the number of APIs are, it's kind of obvious, like the number of APIs are growing. So like, obviously attackers are looking for something they can find and research, and so it's not a surprise here. I also like this iceberg thing, and what I really like is the change in the way how people think about protecting their apps and APIs. If, like 2 years, 3 years ago, it was a very rare thing when people were thinking and asking us, hey, I have so many APIs internally, like what should I do about that? So it was a very rare thing. So now I think like we have a good amount of our customer base which actually think about it. They ask questions about like how to analyze the east-west traffic, internal traffic that is only, like possible to see being inside. So I think it's a good trend overall about like the way of thinking, but we'll talk and unpack these things like while talking about the principles of API security today. So
yeah,
back to you.
Yeah, so let's move on to those principles. The point of this first section is really just to say that API security has a particularly important place in terms of the cybersecurity conversations today, both because of the incidents and also because of the foundation that's driving those incidents. But we're here to talk about the 3 key principles. So let's move forward to that. And I'm just going to jump right into the first principle, which is that you can't protect what you don't know about. Now, this isn't a new saying. This is could be considered an old adage in cybersecurity. You can't protect what you don't know about it. But it does certainly apply to APIs. And the way that this principle is realized in terms of APIs is with API discovery. So we believe that API discovery really needs to be the source of truth for your APIs. Out there, you have APIs deployed. If you don't know about them, you can't protect them. And we know from our first little piece of the conversation that those APIs are exhibiting risk in your environment. So what does this surface look like? Well, here we can use a little bit of information from Gartner, which predicts that by 2025, less than 50% of enterprise APIs will be managed. So what does it mean for an API to be managed? Because a managed API doesn't necessarily mean you don't need API discovery either. So first of all, there are tools called API management tools or API gateways that provide some visibility. But there are lots of APIs out there, generally speaking, that aren't managed by those tools. And those tools don't always provide all the capabilities either. So Stepan, do you want to add anything about unmanaged APIs or the trend that we're seeing there?
And yeah, overall, and I like this example. I bring this up every time we talk about API discovery. We have a conversation with the security leaders and product security professionals out there. And a very simple question we ask in the very beginning of the conversation: do you know how many APIs you have? And this is a very simple question people don't have an answer, because they really don't know how many APIs out there. They don't know how many API endpoints out there. And even if somebody is asking and actually can give you an answer, let's say like 1,000-ish, you will ask, how do you know? And people start to refer to the docs and the like something that they have configured at the API management layer. And those are good sources. Like, that's great that people have it, but like at the end of the day, there is no one unified catalog of what are the APIs out there. Because as you said, the trend is that a lot of the APIs wouldn't be unmanaged soon. So even if you have like properly configured part of the APIs at the, let's say, Honk API gateway or APG, there is a good chance there are like a number, dozens and maybe hundreds or even 1,000 APIs out there that are not managed by the API management platform. So that's why it's crucially important to have, like one solution that basically can give you clarity. And we'll talk more about this.
Yeah. And of course,
just as an aside, guys, Merle observes that it could also depend on how folks define APIs. So that might also enter into what is being managed and is not. That's
true. I mean, to be fair, if you don't, it goes back to the principle, you can't protect what you don't know about. You could also say you don't know about what you don't know about. So if you have an API in your environment that you don't consider an API, that doesn't mean it doesn't present any risk in the environment. It's still something that needs to be discovered and managed.
Yeah, and Merle goes on and points out that, look, we could be talking about production, non-production. We could talk about QA, UAT, all of that, could be open, might need protecting.
Absolutely.
Good point on the definition of the API, by the way, because everybody thinks about this differently. So I think, speaking of the API discovery, it's crucially important to see APIs as granular as only possible. Let me give you an example. So like somebody can say, hey, we have an API for the checkout. But in reality, it's like it can be 30 different API endpoints for the checkout. All of them has their business logic. All of them can be vulnerable to their specific vulnerability. So you really need to think about this as like 30 different APIs, maybe API endpoints. Some of them can be, post API. Some of them can be delete APIs. It can have the same name, same version, but there would be different business logic behind it. So like when you think about the APIs, I would suggest to have a very granular definition of what is the API is. I think from a security perspective, it's the most adequate way of looking at it.
Yeah. Well, so let's talk a little bit about some of the problems that occur with unmanaged APIs, because we talked about unmanaged APIs as a problem in itself, but it's really that there are other problems that they can surface, other risks they can surface in the environment. So we've outlined a few here, right? You've got shadow APIs. These would be APIs that you don't know about, so you don't know they're there and they're potentially being used. Zombie APIs, that might be a deprecated API that shouldn't be there, but is still being used. You also have unused APIs that you don't know about, which would be APIs that are just, unused, that were once used and are now unused. You could throw legacy APIs into that. But the key is that these problems all define or expand the attack surface or the risk surface in the environment. And you have to know that they're present in order to be able to protect against the risk that they exhibit. That's the key. So there are sort of hidden problems when you have unmanaged APIs. And we can move from there into, what are the requirements for API discovery? So if you're going to go down the path of implementing API discovery or an API discovery process, what do you need to think about in order to be successful? So the first one, obviously, it has to be able to tell you where your APIs are. Discovering all of the APIs and endpoints in your environment. As Stepan pointed out, there can be multiple endpoints that you might think of as a single API, but are really multiple distinct endpoints underneath one application. So you need to be able to discover them all, including those shadow APIs, those zombie APIs, deprecated endpoints. And then from there, you need to know more than just where they are. You also need to know what they are. So what are these APIs? Are they delivering different types of services? Are they part of different environments, which was just brought up, right? Is it development? Is it staging? Is it production? All of those are relevant to API discovery. And then are they yours or are they a third party? So who has responsibility and accountability for that API? Is it you as an organization, or is it somebody else's API, part of a third party product? Those are still part of your attack surface as well, and that's important. And then finally, you need to understand what data those APIs expose. There's obviously things like PII, financial data that might be exposed, credentials themselves that might be exposed as part of that API. So when you look at API discovery as a function, as a process, making sure that it answers the where, the what, and the what do they expose are key requirements for API discovery.
Yeah, some would say that, hey, you not only need to know what are the APIs, but also like related risks and related security issues. So like, that's why talking about the API discovery, we usually mention posture management. It's kind of great if you can have visibility about like what are the APIs out there, which of them carry and handle personal data, but like to see the risk associated, because ultimately it's always a question, hey, what are the APIs we should take care of first from a security perspective? And if you have like a lineup of the APIs by the risk score, like an explanation of why you should do X, Y, Z, it can just help you to prioritize your security efforts, because obviously our capacity of security teams across the globe, and we see this across the board, are very, very limited, unfortunately.
Yeah.
So Daya asks about how do you discover third-party APIs if we don't know them as an entity?
Yeah, so like it brings us to the conversation about like how you can identify the APIs. And can you actually switch to the next slide? We can kind of piggyback on this a little bit. So we're discovering APIs is hard. There's no solution that works for everyone, because ultimately everybody has different environments. Like somebody's in AWS, others in GCP, somebody is using API management, others don't use it at all. Someone has one team, another company would have like hundreds of different teams that are producing API. So it's really, really, there is no silver bullet here, but what's clear is that you need to have processes, which is A, and B, you need to have tooling in place. And by processes, I mean, like writing the docs and very like high attention to the hygiene of like what do you document on the API management system. But unfortunately, what do we see? And based on our experience, you will always have something shadow. And the only way to identify this is actually to have some tooling in place that can analyze all the traffic. And based on the actual usage, of your exposed APIs, internal APIs, or maybe even connectors with the third-party APIs, based on the actual usage and traffic, therefore, you can actually have this, inventory of what is out there. And it doesn't necessarily mean you need to buy solutions. For example, we have this slide here. There is a tool which is called API Clarity. It's actually maintained by Cisco. It only works in Kubernetes environment, which is a big limitation. But if you are a Kubernetes shop, you can go there right after the webinar, start using it, and basically have the list of all the APIs that are consumed and used in your Kubernetes-based environment. Unfortunately, you will need to find the solutions for kind of tooling for whatever you're using out there. So that's why, unfortunately, what do we see across the globe, especially if you're kind of mid-market enterprise company with a lot of developers, a lot of environments, you actually need to switch to some kind of commercial tooling which has connectors to all those cloud platforms, multi-cloud environments, cloud native, Kubernetes-based stuff, has connectors to, different API management like Conk, APG, and so forth, because once you have all those connectors, you can actually have the one unified, kind of really detailed picture of what is out there. And that's typically our recommendation.
Yeah, thank you, Stepan. And I think you can think about it from, as a range of activities. At one end, you have manual processes. You can just ask questions about the products that are deployed in your environment and the products you're developing. And at the other end, you've got, commercial tools that are designed specifically to do this task. So taking some action is better than no action, generally speaking.
Totally.
So let's move on to the next principle, number 2 that we wanted to talk about, which is that eliminating 100% of security issues is impossible. So we all would love it, of course, if we could, as security practitioners, sort of actually be done with the job of eliminating risk and have it all gone. But the reality is that there is always residual risk, residual security issues that need to be managed. And that's why it's important to have API protection in place for the security issues that you can't eliminate. And when we talk about API protection, we're talking very specifically about detecting and blocking attacks against APIs. So there are all kinds of attacks out there, lots of interesting attacks to talk about. I don't know, Stepan, if you have a favorite attack that you like to talk about from the list, or one that's not on the list up here.
Not really. I think you mentioned already that there is OWASP and API OWASP, which are two different things. I would say it's more kind of like OWASP top 16. It really should be, and I hope like next year, maybe with the community, we can make it a one unified list, because currently, if we talk about the API security, you basically need to look into these classical WASP, injection and others, and then you need to switch to the OWASP API security, which is not a substitute, it's just like the additional thing where you learn about this kind of bullet attacks and others. Unfortunately, there's like a lot of out there happening, and it's not clear how you can, make sure that all of the APIs that you have in production are totally free of vulnerabilities. It's just like, as you say, Tim, it's not possible. There is always will be something out there vulnerable. It can be injection, super kind of simple vulnerability in a way, but the consequences of having something in production with a SQL injection, it can use like all the fancy API framework, and you would be thinking, okay, the framework is actually handling all the stuff related to the injections, and in many cases you would be right, but in a few cases when you're not, that can be a security breach. And like we see this across the board, I think there's a lot of misconception about the injections and APIs, because like first, injections are not only SQL injections, SSRF is also type of an injection in a way. And there's like multiple others, like Chris can talk about that, but basically analyze the publicly known CVEs for the API vulnerabilities, and we attribute it to different types of the CWEs. Like I think the quarter, please correct me if I'm wrong, but like the quarter of all the vulnerabilities out there are related to some kind of injection attack. So just be mindful about thinking about like your new API frameworks, that claim they will handle an injection of this kind of stuff are, data showed it otherwise. It's just like a lot of things out there that you wouldn't even think that applicable to the APIs are still very relevant.
Yeah. So as we talk about API protection, there are also a set of requirements that you should think about if you're looking at how you can protect your APIs from the security issues that remain in your environment in production. So the first place is, of course, what can it actually stop? What attacks does it support detection and blocking for? And it's important that you look at both the modern and the legacy attacks that occur there. Just because an attack attacks an older vulnerability or uses an older mechanism doesn't mean that it's still not relevant, and that's important. Protocol support is also important. So if you've inventoried your APIs, or if you understand what API protocols are in your environment, making sure that whatever you're putting in place for API protection supports those protocols is important, because if it doesn't, then you're leaving risk open. And there are other ways that you need to make sure that it's flexible to suit your environment. Can it be deployed in the places where it needs to see traffic? Because of course, if you can't see that traffic, you can't detect and block those attacks. But detection and blocking, detection isn't just the only thing. You also have to think about how quickly that capability can react. That's the blocking component of it, really. And the key here is really real-time inline blocking. So if you have a capability that's watching traffic but isn't in line with that traffic, it's going to have a harder time taking action on that traffic. Might need an integration with something else, and that might be viable in your environment, or it might not be able to respond as quickly, and that's important. And then finally, the response isn't just blocking, it has to also help you respond. So when you think about a tool or even a process, you have to think about how to operationalize it. That means integrating with the other tools you have. And we sort of think in two categories. There are enterprise tools, which are things like sort of ServiceNow. I'd put in that category. Jira, I might put in that category. Things that kind of help you get work done. You could put some of the analysis tools in there, like a SIM, Splunk, that kind of thing. And then there are also DevOps tools to integrate with. So if you've gone down the path of, a DevOps process, being able to integrate your response with the DevOps tools you have is also very important. And you need to be able to customize what those responses are. So the ability to customize the response process or the response result is a key requirement for API protection as well. And I think, there are multiple tools that kind of have overlapping capabilities around API protection, multiple categories of tools. And Stepan, you wanted to talk a little bit about what those tools look like and sort of what sits in each category.
Yeah, absolutely. Absolutely. I think the right way of looking at it is I think about the layers, like of API protection. So like, just getting back to the principle, there is always will be something vulnerable in your apps and APIs. Nobody will argue with that. And if somebody will say, hey, we don't have anything, we had this funny conversation with another company the other day because the engineering manager was pretty confident they fixed everything they have in production. And he was basically saying, hey, there's no vulnerabilities in production. Like, why do we need this? Which is, I think this is a very good attitude to live in because live with, because you're just sleep very good at night. But unfortunately, there will be always something vulnerable. And it's all about what kind of controls you can put in place to mitigate the consequences of having something vulnerable. And the good news here is that basically you can have a lot, quite frankly. So I'm typically talking about these three layers: API gateway, which is kind of fundamental thing, like WAF or WAP, which is kind of another name for WAF, and also this API security, kind of advanced API security tooling. Let me unpack every of them. So our API gateway, I think this is a fundamental thing. API gateway, another way, API management. This is a very important piece for your API security program because you need to have API authorization, API authentication in place. And this is basically the best way to organize the whole thing. If you have all those internal microservices, you can set up the MTLS, or an API management like service mesh can also be a good thing here. But also, when we talk about the API abuse, somebody is causing harm with the way how they use API. For example, they are sending too many requests, and your APIs are suffering, the performance is degrading. So API management and API gateway is great because you can use the simple things like rate limiting, and those would be a very effective way to secure APIs against this kind of abuse. The good part, there are a lot of open source API gateways out there, which are, a lot of people will say, hey, they are the best ones. Like Kong API Gateway, which is a partner of us, Tyke API Gateway, which we also work with, Ambassador, which is kind of new API gateway based on the Envoy proxy. So you can choose whatever you have, and probably you already have something in production. So that's a good start already. And if you're not using rate limit and this kind of stuff, I think this is a good time to revisit this. Then switching the gear to the second layer, like WAF and WAP. Speaking about the WAFs and WAPs, one thing that I always like to talk about is go to your WAF vendor just to make sure that they can do simple stuff with the APIs, because you would be surprised how many of them don't really parse REST API calls. They just apply the rules or whatever they have to the whole request without really understanding what is in the input it into the JSON. And as a result of it, you have a lack of visibility what's going on there. But anyway, WAP is a good start. You can do the Gale fence, and in many cases, our API gateways can do something like sample simple really as a positive security model where they compare the incoming API call with the schema and see if there is a match, or like if the request is off, they can block it. It's a simple thing, and we have it, by the way, as an open source solution. So like I'm always laughing, hey, like if it's really what you're paying for, maybe you just go like and use the API firewall. Just like there's a link on the slide here. Maybe Chris, you can share it in the LinkedIn comments as well. But basically, this is a cloud native, very simple and very performance tool that you can use a sidecar proxy and analyze API calls and enforce the schema. So like you can use it to enforce the schema of a request, but also to apply the enforcement for the application response. And then the last one, I know that we talk a lot about this already, is different kind of API security tooling, where you do something like deep API request inspection, really understanding what is going on within the API call, where you do the API discovery, which we just discussed, where you can take the OWASP API security framework and basically use it in production by seeing where you are right now in protection against every of the threat described in the OWASP API security top 10, and a bunch of other things like API abuse prevention, this kind of stuff. Unfortunately, most of this tooling are commercial tooling, but if you have a pretty heavy API estate, probably this is the solution at some point of view.
The other aspect that I think is important to think about when you look at these layers is we talked about it on the previous slide, is the deployment location, or the ability to deploy in all the places where you would need to see the API traffic. And so if you're evaluating products or capabilities you already have, you don't not only have to evaluate them against what they can do, but also where they can be deployed, and if that captures everything that you need to in terms of protecting your APIs. I think that's an important aspect to consider.
Totally.
Good. Okay, well, let's move on to the third principle, which is the earlier the better when it comes to risk reduction. Now, this is an interesting one because I am guilty of, and I've heard lots of people quote this statistic, that it costs 100 times more to fix a defect in production as it does in development. And behind this particular principle, we're really talking about API security testing. And so when people use that cost justification to justify a testing program, to say, it's going to cost us 100 times less to fix this in development than in production, I went and looked into this statistic, and I found that actually it either has no basis in reality, or at best the study that drove that particular statistic came from the 1980s and was based on development practices that probably still exist somewhere today, but the majority of organizations are not using it any longer. So if you're trying to justify testing with a cost argument, I want you to shift from cost to talk about risk, because it's risk that matters in the context of security. So let's talk a little bit about how development has changed, that's driving us more towards a risk conversation than a cost conversation. Because what we've seen over this time period, you can go back to the 1980s if you want, but you don't have to go back that far, is just an amazing shift in the velocity of development organizations, in the ability to deliver services and capabilities to market. We talked about that evolving tech stack at the beginning of the webinar. And that drives a much faster pace of development, which in turn drives more security issues released into production. There's also a competitive angle that drives this as well. So competition, including massive rounds of funding, have driven this kind of explosion of online services that are backed by a DevOps process, if you will, and more aggressive plans for product and development teams. That in turn speeds up the just sheer lines of code that are being pushed to production. And so we're seeing more and more security issues that get released because of that fast pace. And that's the problem that exists, is that those issues get released into production and then that risk is now exposed. So the key for security testing is that a risk that you can eliminate, a vulnerability you can eliminate before it goes to production is just significantly harder to exploit. I won't say it's impossible to exploit a vulnerability that never gets pushed to production, but I will say it's significantly less risk if it's never pushed to production. And so that's what drives, that's the problem behind the need for API security testing. So if we move on to what are those requirements that you need to consider when you're looking at a testing program or a testing product. The first is, does it fit within your environment? So you have some kind of a development environment, probably a CI/CD pipeline of some kind, and that involves a whole bunch of tooling. And you need to make sure that the testing product or testing process that you're looking at can actually integrate into that environment, can be operationalized, as I mentioned earlier. Ideally, it can leverage some of your existing tests to help you jumpstart testing, help you be more effective, help you leverage the work that you've already put in around testing in general. And then second, you want to make sure that that testing effort is connected to the real world. It's not just a development effort. Can you actually use it to validate vulnerabilities that are related to actual attacks that are occurring? Make sure that you're testing things that matter in production. Can you build tests based on the schemas that you've discovered in production so that you're testing what production looks like in the development environment? This connection back to production, to the real world, is important when development moves at the speed at which it does today. And then finally, you need to make sure that that process or that product is sufficiently customizable for your needs. Does it allow you to configure it the way that you need to for different teams or different pipelines in your environment? Does it enable those teams to build custom tests specifically for the APIs that they're developing? Those are all important requirements to consider when you're looking at API security testing. And if we jump forward, there are lots of tools actually out there that can help you get started with API security testing, right, Stepan?
Yeah, totally. Can you just get back for a previous slide?
Yeah, absolutely.
I just wanted to give you a little bit of a history. When we started to work on the API security tooling, specifically on the testing part, 4 years back, I was fascinated. Like, most of the security tooling was just not adequate for the APIs. Surprisingly, because so many applications were already API based.
But that's the problem we were talking about before, with the tech stack moving at a pace, outpacing the security tools, right?
Exactly. I was just blown away. There were no, people were asking, hey, what kind of tool will you recommend? We can pay money. What kind of tool you can recommend so that we can incorporate API security testing into CI/CD pipeline? So that we basically have it as a part of the development process. And we did a research, and believe me, we tried everything. There was literally nothing that was working that was good enough, even for the REST APIs. I'm not even talking about the gRPC and GraphQL and others. There were just nothing out there. And today it's 2023. You will ask what's changed since then? So there were some good movements. Yes, obviously, all the AST, application security testing vendors, are now talking about the API security. And the good part, they're also working on implementing some of the stuff. But it's still we had a conversation recently at the Gartner Security Summit, and we've been talking with somebody who's very knowledgeable in the API security space. And me and Tim, we asked questions who do you think the best in the API security solution to test APIs? And there was no clear answer, because it's still a kind of a very green field. So that's why it's interesting to talk about this, and it's interesting to research the whole thing. Testing APIs is not easy. APIs are not applications. You can't crawl applications. APIs have some kind of internal state that is really hard to know from the outside. The sequence of testing is also important. For example, it doesn't really make sense to test API for the checkout of the order if you don't put anything into the cart. I'm talking here about a kind of hypothetical e-commerce shop. So you need to add some kind of items into the cart first, use one API for that, and then you can only test the checkout API, because this is where you can actually see the execution of the business logic. And so I can talk a lot about that. It's really, really hard. And there was, if we switch to the next slide, there are some great, research projects about that. For example, Wrestler this is the item number 2 here, is the research project. It's kind of like open source tool, but it's more on the research side coming from the Microsoft, because they are trying to solve this. They say, hey, how to test those APIs if there's a state and there's a business logic and the sequence is important? Can we make some assumptions based on the API specs and this kind of stuff? So like I would recommend to take a look into it because it's really, really interesting. Like, and it came in from the Microsoft research. Dread is also kind of like similar thing to take a look. And overall, I will not talk about everything that we have on this slide, but these are some of the open source tooling that you can incorporate into your development pipeline and security tooling. Obviously, everybody who is in the product security for a while know the Project Zap. So like they've been better to test APIs recently. So like this is something you can use. A lot of questions we have about how to load test APIs. Like to see if your guys really protected against DDoS and different kind of API abuse. So tools like AB or JMeter can be helpful here. I want to give some kudos to our teammates who've been working on the GoTestWAF tool. So this is what we call a simple attack simulation tool. And this is just a great thing. If you have something like a WAF or maybe API security solution, and you think it's good, just go there, do the Git clone of repository, run a simple script, and it basically gives you the PDF report of how your APIs are protected against different type of attacks. And like what we see, there's a lot of surprises, especially recently from customers across the board. So like it's really, really give you a simple question, simple answer. If your existing tooling actually, can identify bullet attacks or can even parse JSON or gRPC or whatever protocols you're using. So this is just a good start. But overall, all those tools are open source. Just go research, shoot questions if you have any.
Yeah. So for everybody who's on the LinkedIn side of the call, I've posted the link to the GitHub. If you're interested in playing around with GoTestWAF, if you're on the Zoom side, yeah, give DM us and we'll send you the link, or as Stepan says, just go into GitHub and look for GoTestWAF.
Okay, some great tools there, some good options to check out. So we've talked about these 3 principles, and we've talked about them a little bit as separate principles and sort of separate capabilities potentially, but I want to emphasize that they're actually all connected. So when you think about API security, you need to think about the whole as much as you do the individual capabilities that we've talked about. So if we sort of summarize it as API discovery, real-time API protection, we talked about API security testing. You could do discovery by itself and protection separately, but you really need to protect what you discover. So there has to be a connection between discovery and protection. And the same is true on the testing side. So you need to be able to test what's been discovered in production as well. You can't test API endpoints you don't know about. So you have to have a discovery function that's related to and connected to API security testing. And then we talked a little bit about the value of developing testing based on real-time, based on the protection. So the attacks that you see in the real world, in production, can drive your testing to make sure it's as relevant as possible and making sure that that connection is there as well. And if you spend time thinking about these 3 bubbles, you'll find that there are more connections as well. But what they really do is they drive you towards an integrated approach. So when you think about API security and those key principles that we talked about, you want to think about them as resulting in ideally an integrated approach to API security that you can use to drive down risk in your environment and ultimately allow you to run your business in a more secure way.
We're a big fan of an integrated approach. So even if you can find, all those individual tools and pieces and try to build something on top of it, this integrated part is always missing. So like by having a visibility into the real attacks happening out there, having the up-to-date inventory of all other APIs, and not only about the APIs, but also what are the changes with those APIs happening throughout the day or throughout the weeks, it really can help you to leverage pretty much everything related to the API security. And A lot of people are talking about the pillars, like the key, we talked about the principles today, but if you want an answer, like what are the pillars of the API security? So like those would be exactly what you see on this Venn diagram right now, is like API discovery and posture management, API real-time protection, and API security testing. So like if those pieces are working together in sync, that's a good indicator that you're on the right track with building your API security program.
That's almost a good, almost a perfect segue into the last section here, which is how Wallarm can help. So we, of course, encourage you to try and check out some of the things that we talked about in terms of open source tools. But when you're ready for a commercial approach or that integrated approach, we also believe that Wallarm can really help in those cases as well. And that's what we do: integrated app and API protection. Protecting billions and billions of requests every day across tens of thousands of apps and APIs for some of the largest customers in the world as well, largest organizations in the world. And we do that by providing, not surprisingly, discovery capabilities. So identifying all of the APIs and endpoints in your environment. As Stepan pointed out, identifying the sensitive data, identifying things like shadow APIs, presenting a risk score for those endpoints to give you that security posture management for APIs as well. Those are all key points for our discovery capabilities that we offer. Stepan, anything I missed there that you wanted to add?
No, not really. Not really. Like when we show them, we typically go into the UI and say, hey, like you're a HIPAA compliant company. These are the APIs that carry all the data of your patients, and let's filter out like those APIs that has a risk score higher than 8.0. So those are the APIs you probably need to take care right now, because A, somebody is abusing them already, and B, these are the vulnerabilities that are associated with them. So it's kind of a clear plan of what to do, because having the inventory is good to have, but the question right after you're having this list of thousands of APIs, what should I do about them? Mm-hmm. That's a part of our job, is basically to guide you into the very specific actions that you can take, in your everyday life.
Yeah, absolutely. And then we also offer API protection. So for the risks that you can eliminate, we want to give you the ability to protect against them. What we've put up here is a screenshot of our OWASP API security top 10 dashboard. This is just one way to visualize the risks and the controls that have been put in place in your environment. We support a wide variety of protocols. We detect and protect against a wide variety of threats, and we reduce effectively the amount of tuning that you need to do for implementation, so that it's easy to implement and that you get protection out of the box with Wallarm. We also, of course, help you respond as well. So that dashboard is one view. There are lots of other views into the details to give you the ability to have a more effective response to incidents that occur. We give you the ability to automate response processes through triggers, the ability to verify that endpoints that have been attacked are actually vulnerable. And we integrate with the tools in your environment that matter, that allow you to actually respond effectively to API security attacks as well. And then finally, we extend that capability into testing. So we talked a bit about testing in our 3 key principles. Testing is also something that Wallarm offers, giving the ability to test apps in development prior to APIs in development prior to being pushed to production, to connect production and development together to do testing based on real-world traffic. We can also extend the QA tests that you're already using and turn them into security tests as part of our testing suite, and really gives you the ability to reduce the risk before it gets pushed to production. So that's the really quick overview of Wallarm. Obviously, there's a lot more that we can say about it, and we'd love to tell you more about it. We'd love to give you a demo, in fact. So if any of that sounds interesting, feel free to reach out for a demo. And we're happy to provide more information about Wallarm specifically as well. And Chris, are there any questions that we've got a couple of minutes left to answer questions? If folks have questions that we want to drill into.
Yeah, we've been addressing them as we go along. Thanks everybody who's been putting their questions into the chat. We don't have a lot that have been left unanswered at the moment. So if you have some lingering questions, certainly let us know.
I see a few like people are sending DM messages me in LinkedIn. So like
okay, there we go.
Somebody's asking like, what is the best way to deploy Wallarm? And can you basically talk about like the implementation process of this product?
Yeah.
Can you talk about it?
I mean, my perspective is the best way to deploy Wallarm is whatever fits in your environment. Our goal is to offer deployment options that meet just about any environment out there. Really, it's about seeing traffic. So we want to deploy Wallarm as an inline filtering node, so that we can see the traffic and we can respond to it in real time. There are options that are not inline if that's not an architecture that can be supported for whatever reason. But of course, you can't block traffic if it's not passing through the node. So we can deploy, and Stepan, feel free to jump in if I'm missing here. We can deploy as a Docker container. We can deploy as a Kubernetes sidecar. We can deploy as a dynamic module in Nginx. We can deploy on a Kong ingress. There are more. It's hard to list them all because our goal is
the philosophy we have is whatever the customer is using, there's always the best way to deploy Wallarm. We are a big fan of cloud native approach. Whatever you have cloud native, Envoy, Kubernetes, there's always a way of deployment. We typically speak about the two buckets. One is out of band when we just analyze the copy of the traffic, and also inline when we use these cloud native connectors to different kind of environments. Typically what do we do is just ask questions about your environment, and our deployment expert basically guide you through what is the best way to implement the whole thing. And obviously, if we talk about the testing, it's more about like CI/CD, and how to connect into your, let's say, Jenkins or GitLab. So there would be another phase of testing where we report the findings back to the pipeline. So it's up to you how to configure it in a way. Do you want to stop the pipeline execution if the vulnerability is detected, or you want to continue? So there are a lot of options, and it's an infrastructure product and the infrastructure project. So you need to, we always need to customize it to your needs.
So that brings up a question from Faisal. What if a company doesn't have a CI/CD process?
No, that's fine in a way that CI/CD in the context of Wallarm is only important for the testing piece. You still have all the discovery, production. With the testing piece, quite frankly, you can use it without CI/CD, but the whole idea here is that you will have the automated testing a part of your development pipeline. So this is where you get the benefits of using this approach.
And then Merle asks, is deployment strictly SaaS or hybrid on-prem?
So it's hybrid would be the best way to describe it. So the two components in any deployment are the nodes themselves, the filtering nodes, and then the Wallarm cloud. So the Wallarm cloud is used for the user interface and some of the analysis, but the nodes can be deployed just about anywhere that traffic flows. So that could be on-prem, it could be in the cloud. It's very flexible for the node deployment.
Yeah, the beauty of the approach we are taking is we like to call it privacy first. So the idea is that all the traffic would be analyzed in the custom environment. So we don't have this requirement where we need to copy or mirror all the traffic into some kind of cloud data lake where we do this analysis. Now, all your data should be your data. The customer of your users and your customers should be, like in your environment. So the idea is to analyze everything in your own environment. So that's why we actually a lot of companies, especially for the compliant like regulated industries, really like the approach we're taking here. So happy to talk more about that.
And we have another question. Somebody joined a little bit late and was hoping you could give a quick recap of principle number 1. Tim, if you could just help them out there.
Yeah, so principle number one was you can't protect what you don't know about. And it was the driver behind API discovery. So the idea is that just as it's true with any kind of cybersecurity, if you don't know about an asset or a risk, you can't work to protect it. And that's true of APIs. And so API discovery is the capability that sort of fills in that principle, if you will. That's the quick recap.
Great, thanks. So we have another question. I'm going to try to get these right. Narasimha, sorry, I probably butchered your name. I apologize for that. 2 questions from SaaS platform scenarios. Is it an on-prem agent on the app servers? And is it after a WAF endpoint?
So it's not an on-prem agent on the servers. It's as we call it, a filtering node. So deployed, I mentioned a bunch of different deployment options where it would be deployed, but not as an agent on the actual server serving the API. And then what was the second part of that question?
Is it after the WAF endpoint? So I'm assuming
in terms of the sequence of traffic. Yeah, it certainly could be. So we didn't talk about it in this particular presentation, but Wallarm works as both for app and API protection. So you can use the Wallarm filtering nodes as WAFs themselves. So you can deploy it as a sort of an all-in-one integrated solution. If you have a WAF that you're happy with and it's deployed, you can certainly put the Wallarm node behind that WAF. And it will capture it'll work on the traffic, capture the API attacks, block them, that kind of thing. It'll also pick up anything that the WAF misses in terms of web applications. So there's some benefit there. So that deployment is also fairly flexible.
And Piotr asks, and again, apologies for butchering your name, is making production API publicly discoverable not a security risk in some cases?
Well, your production APIs are already essentially discoverable because they're public. So we're not making them any more discoverable, except to you as the customer. We're collecting that information so that you can actually see them. But those APIs, if they're public, are essentially discoverable for an attacker in that sense. So maybe I don't understand the question, but it seems like it's not we're not changing the exposure of those APIs by providing discovery.
Yeah. And then
it's more about giving visibility what is actually exposed.
Yeah.
The way the product is built, that you can see the split between what are the APIs that are only internal versus the APIs that are also exposed outside. So you will have this visibility.
So let's see. Tony asks, is your product based on OpenResty?
OpenResty is the fork of Nginx. So we have the what we call plugins to the load balancers. So in this way, if you already have, let's say, Nginx or OpenResty or Envoy somewhere in your environment, the deployment can be as easy as plugging in the module into this existing load balancer. And we have, from this perspective, it can be super quick and easy, maybe in 10 minutes, you can get it up and running.
Great. Let's see, we have time for a couple more. Pramod asks, what are the minimum best practices needed to keep in place basic e-commerce application security?
That's probably a longer list than we can explain in a response to a question. It depends on first of all, the architecture of your e-commerce environment will drive what best practices are most applicable. Depending on where you're deployed in the world, you'll have different regulatory requirements that are relevant there, and then the actual architecture might drive specific best practices for those technologies. That being said, I think the 3 principles that we talked about actually apply more broadly in this case. You have to know what's in your environment so you can protect it. You have to apply protection to it, and you have to put in place a program or a process to prevent risks from being shipped into production. if you can do those three things, if you can follow those three principles, you're in pretty good shape from a security standpoint.
Yeah. Great. Well, we're at the top of the hour, actually a little bit past. So thanks, gentlemen, for your time and explaining all of this. And thanks to our audience for joining us and giving us all these great questions. Really appreciate your time. If you find you have questions later, you can always DM us, as you've apparently been doing all along to Stepan. So keep them coming. And we'll follow up if you've registered via the website. We'll follow up with the recording and slide deck.
Thank you, everyone.
Great. Thank you, everyone.
Thanks.
Thank you.